Assalamu alaikum, dear friends and colleagues. We are continuing the AC schooling weekly series. In today's lesson, we will discuss how low voltage affects the performance of both on-off and inverter systems. Most AC units operate on 220 to 240 volt, and according to international IEC standards, a voltage fluctuation of plus or minus 10% is within the permissible limit. Theoretically, a compressor can burn out due to excessive overvoltage. However, in my 20 years of experience, I have rarely seen a compressor fail specifically because of high voltage. The vast majority of failures we encounter are actually caused by undervoltage, low voltage. How does low voltage kill a compressor? The point is that the motor is forced to draw more current to amperage to maintain the same torque and power. The power formula tells us P equals V times I times cos phi. When voltage drops, the current must increase to perform the same amount of work. This excess current overheats the windings, shortens the life of insulation, and eventually burns out the compressor. Overheating of the compressor also means inefficient energy consumption and a significant loss of cooling capacity. In on-off systems, if the voltage drops by 10%, the unit might still run, but the cooling performance will noticeably weaken. But what happens if an inverter unit receives 180 volts? The inverter's brain tries to compensate for this drop. However, to protect the main PCB and the compressor, the system automatically reduces the compressor speed, frequency. This means that although the AC doesn't stop completely, its cooling capacity will drop sharply. Essentially, the inverter unit limits its own power to prevent burning out. Additionally, during low voltage, the capacitors and power modules IPM on the auto unit's main PCB overheat. Operating under long-term low voltage exhausts the lifespan of these sensitive electronic components and leads to very expensive repairs. Low voltage also causes the indoor and outdoor fans to spin slower, which disrupts the heat exchange process in the evaporator and condenser. Sometimes the voltage drop is caused by loose electrical connection or worn out contactors points rather than the power grid itself. In developed countries, voltage is strictly regulated, but in many regions, due to different infrastructure, it can be unstable. Low voltage can result from unbalanced phases or long distances from the power transformer. In such cases, the best course of action is to notify the local power utility. When no other option is available, installing a voltage stabilizer suitable for the unit's power can partially solve the problem. Remember, the lifespan of an AC unit directly depends on voltage stability and regular maintenance. We prepare these videos to help our technicians. Don't forget to like and subscribe. Thank you for watching us until the end.